Hello, everyone, and welcome to this Telit webinar, How Next-Gen GNSS is Positioned to Power Up the World of IoT. I'm Amanda Flink, the Head of Global Events here at Telit, and I'll be moderating our webinar today. Let's get to know our speaker real quick. To explain this topic today, I'm pleased to be joined by Gianmarco Zanda, Project Manager at Telit. Now, just before I hand it over to Gianmarco to start the presentation, I have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of our presentation here. Simply submit a question by posting in the questions box, which should be located at the bottom of your screen. Also, be sure to check out the resources section for some additional information on our topic today. And finally, we will send out the replay link to all attendees at the conclusion of our webinar. And with that, Gianmarco, I will hand it over to you to kick us off.
Thank you, Amanda. Hello, everybody. My name is Gianmarco Zanda. I am Product Manager for Location Technologies at Telit. And today I will talk about how Next-Gen GNSS is positioned to power up the world of IoT. In particular, today I will start with a brief Telit introduction, following with an overview of GNSS and positioning technologies. Then I will discuss a little in deep some satellite positioning use case and how the GNSS and next generation GNSS integrates into your business application. And finally, I will report some brief conclusions. Telit is widely recognized as a leading enabler and a solution provider for the Internet of Things. We are at the moment at the core of the IoT business, offering products and services for companies of all sizes that rely on mission-critical connectivity, security, and scalability, and are looking for enterprise-grade performances. Our customer can use our modules, like the edge hardware on the left, our connectivity, as you can see, our next connectivity offering, or our platform separately, like device-wise, or they can bundle together as an integrated end-to-end solution, like is our One Edge platform solution. Our integrated solution, of course, offer reduced complexity, risk, and time to market versus the in-house engineer of a full IoT project. Telit, as a solution provider, offer products and experience on a broad ranges of technologies for optimal results and satisfaction of its customers. Today, in particular, we'll focus on satellite positioning technologies and how they are the key for enabling new verticals in the expanding global navigation system satellite system market. In this slide, I am offering you a brief overview of the positioning technologies available currently on the market and their average accuracy. As you can see on the right, there is a single cell and multi-cell positioning based on a triangulation of the cellular towers and from them retrieving an approximate position of the device that is in the range of hundreds of meters up to kilometers. And on the left, we are moving towards Wi-Fi and Bluetooth technologies. And finally, the satellite positioning, that is so GNSS single band, GNSS multi-band, and then the GNSS enabled technologies like real-time kinematic or precise point positioning and the hybridation of these two. As you can see, the approximate positioning can be achieved via multiple technologies, but only GNSS enables sub-meter and even centimeter level accuracy. As you also in this slide, for example, you can notice that Telit One Edge portal integrates location features that use both cell ID positioning and GNSS positioning if available. In particular, our One Edge portal covers the accuracies from few meters to kilometers, depending, of course, on the technologies available. In particular, also in this slide, in light blue, I highlighted the position technologies enabled by Telit, for which you may need a third-party service to achieve, let's say, the real-time kinematics or corrections, for example. In the next slide, I will start now focusing on the GNSS receiver themselves and how these are relevant for the market. According to several analysts, the market size of GNSS will reach more than $350 billion in the next 5 years' time. The increasing demand for high accuracy, as I showed before, can only be satisfied with modern satellite receivers. In the past, in particular, the support for multiple constellations increased the availability of the positional fix in every area, or also, let's say, less covered area of the world, while more recently, the introduction of multi-frequency receivers at affordable price is allowing improved accuracy and reliability for the mass market deployment of devices. The combination of high rate navigation and improved accuracy allow the GNSS receiver to play a pivotal role in the new verticals like autonomous robotics and unmanned device and smart agriculture. However, achieving the correct performance requires the correct integration of the GNSS within the customer infrastructure. In this slide, among the several applications that Telit enables with its products, I identified a few use cases where GNSS is the key component. In addition to GNSS, though, the bundle with other radio technologies like cellular, Wi-Fi, or Bluetooth is required for the correct communication and integration in a modern infrastructures like cloud and management portals. As shown in the picture, on the left side, insurance telematics, maybe, for example, the black box for the car, or the fleet tracking, and in general, the asset or people tracking, are technologies that are already exploiting GNSS capabilities. However, the last generation receivers, in particular the addition of multi-frequency support and the increased update rate navigation, allows also these established verticals to take advantage of the improved performances with minimum effort. Likewise, the satellite-based timing applications, often used for precise synchronization of devices, will benefit from the more reliable modernized GNSS signal, like the Galileo E5 band, for example, and from the high rate navigation that allow a higher update rate also of the timing. Finally, within the autonomous robots, we can include all the next gen application, like I was mentioning before, the self-driving devices for smart agriculture, the unmanned drones for logistics, and for example, the precise surveying robots for construction and reporting applications. Among the other applications, as I was saying before, as GNSS system continue to improve and evolve, the IoT and cloud-based possibilities are increasing and becoming almost endless. Stepping a little aside from the previous examples I showed, I present here 5 little broader areas that all the businesses should consider now and in the next years if they want to take advantage of the GNSS application. As the first one, the asset connection with a network. Modern devices are already capable of geofencing and reporting alerts when the asset or the device is moved. So in this case, the latest low power and energy efficient technologies allow longer battery for the devices, and the latest advancement and the integration of the cloud-based computing allows to increase the number of the tracked device and managed device, and the application to offload some of the calculation from the device to the cloud. While a little broader again, the intelligent vehicles and highway systems, where I indicate in this area the more broader autonomous driving new technologies. In this case, not only the GNSS receiver can provide improved performance, but the integration with the other IoT devices and communication can also provide and assist the drivers with traffic and forecasting information. Along with the fusion of external sensors, the GNSS combined with IoT, it will be the core of these new verticals and new technologies in the next future. Regarding the health and safety, from medical alerts to the tracking of patients and valuable medical equipment, the combination of GNSS and IoT can not only save lives with critical real-time information tagged to a location, but also increase the efficiency of monitoring vital symptoms. For example, also for the use of the last generation increased accuracy and new devices higher update rates, it can help in reporting the exact location of an accident with an error of just few meters rather than hundreds of meters as may be reported with only cellular technologies. As another area, as I was mentioning before, the clock and time synchronization, where that includes all the application related to the time synchronization. And this kind of application is increasing rapidly, like telecom networks, electrical grids, and also now finance rely on accurate, precise, and coordinated time. So the synchronization and transfer of the universal time can easily be accomplished with the accurate timing provided by GNSS and transmitted by other IoT communication devices. Finally, least but not last, the security is with the improvement of anti-jamming and anti-spoofing protection for civilian user. The latest GNSS technology is providing a more robust and secure system for preventing theft and other interference on your IoT application. In particular, the use of multiple frequency offers a backup in case of jamming attempt on one of the other frequency bands. Let's say that these additional lines of defense will help ensure that the devices and the system connected to them won't fall victims of hackers or, in general, the attempt to misreport the location. A next step on the integration of GNSS technologies within modern application, there are probably two major approaches for this integration. One is to have a GNSS embedded in a cellular application that is very common in smartphone, but also in IoT devices, or to have an external or standalone GNSS that usually provides improved capabilities or performances. For example, on the left, the embedded GNSS has the advantages of having a unified interface, slightly higher power consumption due to the cellular part of the device, but is a self-contained solution, and it offers the advantage of being already approved at module level also for certification like FCC. On the other hand, the external GNSS require interface with the GNSS receiver and with the MCU and or with the cellular device. But it offers the best power consumption options because it allows to switch off all the other non-required part of your application, although it of course requires this additional design to integrate multiple technologies. But in general, the external GNSS, for at least for the mass market produced on, let's say, IoT end devices, are the only one that allows navigation rate above 1 Hz, that supports multi-frequency GNSS, and it also allows to export raw measurements that are used for real-time kinematic and post-processing kinematic applications. Finally, the geofencing that is a feature that is already embedded in the majority of external and standalone GNSS. Finally, I can move to my conclusion slide, where I can recap that the modern GNSS device can provide high performances at a fraction of the cost they had in the past, allowing mass market distribution of them. The multi-constellation and multi-frequency devices combined with high update rates are the building blocks for the autonomous devices' new verticals that are becoming that they will be the standard in the next generation. In addition, the integration of these GNSS and other IoT with the cloud will unlock new market opportunities. Furthermore, the modernized GNSS signals, like I was mentioning before, the GPS L5 or the Galileo E5, are more reliable and then less prone to errors than the past. And thanks to anti-jamming and anti-spoofing technologies, they offer an increased level of security. Finally, the ongoing optimization of chipset and the receiver power consumption will extend the lifetime of each device, the life use of the device, and the use case for battery-powered applications. I think that's all for today. I thank you for sorry. I thank you for your time today. And again, I am Gianmarco Zanda, product manager at Telit, and I leave now the word to Amanda.
Great, thank you so much. Before we get to the questions here, I am going to drop a poll on your screen. If you would like to have one of our experts contact you, please do respond here on the poll and we will get someone to reach out to you directly. It looks like we've gotten just a few questions, so we'll just go ahead and dive right into those. Gianmarco, the first question I got here, can you tell us the advantages or the disadvantages of using GNSS compared to other technologies?
Sure, Amanda. Thank you for the question. I would say that the main advantages of GNSS technologies is that it is an independent technology, and that is the only one that can achieve meter and submeter positioning. So it does not require, let's say, other infrastructure beyond the device, the receiver, and a good antenna. Among the disadvantages, the main one and the obvious one is that it doesn't work indoor because the GNSS signal is received directly from the satellite, so it's a very weak signal, and it can be blocked within the buildings. In that case, the integration with partner technologies or a bundle between GNSS and either Wi-Fi or cellular is the best option for having an approximate position in all conditions. I hope I answer your question.
Yeah, we'll see if they need any further to that. The next question I have here. So I know you covered this just a bit here, but maybe you could give us a few more key points. What are the main differences between embedded and external GNSS? Why would someone choose one or the other?
Thank you for the question again. As I highlighted briefly during the presentation, the main advantage of the embedded GNSS is the simplicity, because it's a self-contained solution, and there is only a single interface where the customer or the user only use the AT commands for control both the cellular part and the GNSS part. let's say that the main advantages beyond the simplicity is that the module is, at least the Telit provided modules are already certified with FCC, and that speed up also the time to market of this solution. The drawbacks of this particular solution is that the IoT tier devices do not allow higher update rate and usually support only a single frequency. So they're usually the L1 band for like the standard GPS technologies. On the other hand, if a customer requires, let's say, advanced features or required to have improved accuracy and improved higher update rates, then a standalone external GNSS is the best solution. And in that case, the drawback is the additional complexity of the design. But on that side, Telit also offers design review for their customer to better integrate the two technologies together.
Great, thanks. It looks like I just have one more question here. This one says, I'm already designing an application with multiple technologies. How could I get help with this process?
In case of if a customer or user is already integrating multiple technologies, I suggest to contact our technical support team that is providing both design review support and suggestion for already started design, but in particular for certification phases where multiple radio technologies are involved. We can also offer some tests on our side to confirm the avoidance of the harmonics and the confirmation of the pass of the most commonly radio technology tests.
Okay, great. Yeah, and if you want to send in your email or another comment there, we'd be happy to connect you with the right people as well. All right, so I believe that's all the questions we've got. So we will go ahead and wrap up for today. Audience, please be sure to check your inboxes in the coming days, and we will send out that replay link. Gianmarco, thank you so much for your time today, and thank you to all who joined us.
Thank you, Amanda.